Line segment. Line segment is the shortest distance between any 2 points. It has 2 endpoints. It cannot be extended in any direction. A line segment can be measured, so it has finite length. AB is a line segment. It is denoted as line. A line segment extended in both the directions becomes a line. A line has no endpoint. It can be extended endlessly in both the directions. Can we measure a line? No, we can't. So, we can say that a line has length that cannot be measured. Line segment is a part of line. PQ is a line. It is denoted as ray. A line segment, when extended to one direction only, becomes a ray. It has one initial point. It has no finite length. Here, OP is a ray. It is denoted as it has O as its initial point. Angle. Two rays having same initial point form an angle. An angle can also be formed when lines or line segments meet or intersect each other at a point. In figure 1, line segments AB and BC meet at B to form angle ABC. In figure 2, line segments AB and CD intersect at O to form 4 angles, that is, angle AOC, angle COB, angle BOD and angle AOD. Types of angles. 1. Acute angle. An angle whose measure is less than right angle is called an acute angle. 2. Obtuse angle. An angle whose measure is greater than 90 degree is called an obtuse angle. 3. Right angle. An angle whose measure is equal to 90 degree is called right angle. 4. Straight angle. An angle whose arms forms opposite rays is a straight angle. Its measure is 180 degree. 5. Zero angle. An angle whose arms coincide with each other without taking any rotation is called zero angle. 6. Complete angle. An angle whose arms coincide with each other after taking a complete rotation is a complete angle. Angle AOB is an complete angle. Its measure is 360 degree. 7. Reflex angle. An angle whose measure is more than 180 degree but less than 360 degree is called an reflex angle. Shaded region angle AOB is reflex angle. 8. Related angle. Angles which are related with some condition are called related angles. The following are types of related angle. A. Complementary angles. Two angles whose sum is 90 degree are called complementary angles. B. Supplementary angles. Two angles whose sum is 180 degree are called supplementary angles. The two angles whose sum is 180 degree are called supplement of each other. An angle of 120 degree is supplement of 60 degree angle. C. Adjacent angles. Two angles are called adjacent angles if they have 1. A common vertex, 2. A common arm, 3. Non-common arms on either side of common arm. In the adjoining figure, angle AOB and angle AOC are adjacent as they have A. A common vertex O, B. A common arm OA, C. Non-common arms OC and OB lie on opposite side of the common arm OA. Linear pair angles. A linear pair is a pair of adjacent angles whose non-common arms are opposite rays.
In figure 1 and figure 2, angle AOC and angle AOB are adjacent angles because
their non-common arms OC and OB are opposite rays. So, angle AOC and angle AOB form a linear pair, whereas in figure 2, OB and OC are not opposite rays. So, in figure 2, angle AOB and angle AOC does not form linear pair. Vertically opposite angles. When two lines intersect, then the angles having their arms in the opposite direction are called as vertically opposite angles. When two lines intersect, vertically opposite angles so formed are equal. Example 1. In the given figure, if angle 1 is equal to 50 degree, find angle 2, angle 3 and angle 4. Solution. Angle 1 is equal to 50 degree. Given. Angle 2 plus angle 1 is equal to 180 degree. Linear pair of angles. Angle 2 is equal to 180 degree minus angle 1, which is equal to 180 degree minus 50 degree, which is equal to 130 degree. Angle 2 is equal to angle 4, vertically opposite angles. Therefore, angle 4 is equal to 130 degree. Angle 1 is equal to angle 3, vertically opposite angles. Thus, angle 3 is equal to 50 degree and angle 2 is equal to angle 4, which is equal to 130 degree. Example 2. Find complement of the following angles. A. 40 degree. B. 35 degree. A. Let Z be the complement of 40 degree. Then Z plus 40 degree is equal to 90 degree. So, Z is equal to 90 degree minus 40 degree, which is equal to 50 degree. B. Let U be the complement of 35 degree. Then U plus 35 degree is equal to 90 degree. U is equal to 90 degree minus 35 degree, which is equal to 55 degree. Example 3. Two angles of a linear pair are in the ratio of 2:7. Find the angles. Solution. Let the angles be 2x and 7x. Then 2x plus 7x is equal to 180 degree. 9x is equal to 180 degree. X is equal to 180 degree by 9, which is equal to 20 degree. So, the angles are 2 into 20 degree and 7 into 20 degree, that is 40 degree and 140 degree. Example 4. In the adjoining figure, A. Is angle 1 adjacent to angle 2? B. Is angle AOC adjacent to angle AOE? C. Does angle COE and angle EOD form a linear pair? D. Are angle BOD and angle DOA supplement? E. Is angle 1 vertically opposite to angle 4? F. Which angle is the vertically opposite angle of angle 5? Solution. A. Yes, angle 1 is adjacent to angle 2. B. No, angle AOC is not adjacent to angle AOE because their non-common arms lie on the same side of AO, common arm. C. Yes, angle COE and angle EOD form a linear pair because their non-common arms CO and OD are opposite rays. D. Yes, angle BOD and angle DOA are supplement because they form linear pair and hence their sum is 180 degree. E. Yes, angle 1 is vertically opposite to angle 4 as their arms are in the opposite direction. F. Vertically opposite angle of angle 5 is angle BOC.
Types of lines. Intersecting lines. Two lines are said to be intersecting if they have a point in common. The common point is called as their point of intersection. AB and CD are two intersecting lines and O is their point of intersection. Parallel lines. Two lines are said to be parallel if they do not meet or intersect anywhere in the plane when extended infinitely in either direction. Or, in short, we can say that two parallel lines do not have a point in common. Thus, if we draw two lines in a plane, then they are either parallel or intersecting. Transversal. A line intersecting two or more given lines in a plane at distinct point is called a transversal. In figure 1, P is a transversal, but in figure 2, P is not a transversal because it intersects two lines at one point only.
Angles made by transversal with two lines. Let L and M be two lines and P is a transversal intersecting the points at A and B. Then L, M and P make 8 angles and we name them as angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8 as shown in the figure below. The 8 angles marked 1 to 8 have their special names. Interior angles. Angles whose arms include AB are called interior angles. In figure above, angle 3, angle 4, angle 5 and angle 6 are interior angles. Exterior angles. The angles whose arms do not include AB are called exterior angles. The exterior angles are angle 1, angle 2, angle 7 and angle 8. Pairs of corresponding angles. The corresponding pairs are angle 2 and angle 6, angle 1 and angle 5, angle 3 and angle 7, angle 4 and angle 8. Pairs of alternate interior angles. The pairs of alternate interior angles are angle 3, angle 5, angle 4 and angle 6. Pairs of alternate exterior angles. Angle 2 and angle 8 and angle 1 and angle 7 are pairs of alternate exterior angles. Example 1. If L is parallel to M and T is a transversal, then find X. Solution. L is parallel to M and T is a transversal. Then X is equal to 60 degree because they form a pair of alternate interior angles and we know that when two parallel lines are intersected by a transversal, then all pairs of alternate interior angles are equal. Example 2. L and M are two parallel lines and T is a transversal. Find X. Solution. We know that when two parallel lines are intersected by a transversal, then pairs of consecutive interior angles are supplementary. So, X plus 70 degree is equal to 180 degree. X is equal to 180 degree minus 70 degree, which is equal to 110 degree. Example 3. If L is parallel to M and P is parallel to Q, find A, B, C and D. Solution. P is parallel to Q and L is a transversal. Then 60 degree plus A is equal to 180 degree. As sum of consecutive interior angles are equal to 180 degree. So A is equal to 180 degree minus 60 degree, which is equal to 120 degree. Now consider L is parallel to M and Q as a transversal. Then angle A is equal to angle C. Alternate exterior angles. Therefore, C is equal to 120 degree. Also, C plus B is equal to 180 degree. Linear pair. So, 120 degree plus B is equal to 180 degree. B is equal to 180 degree minus 120 degree, which is equal to 60 degree. D is equal to B. Vertically opposite angles. So, D is equal to 60 degree. Example 4. In the figures given below, decide whether L is parallel to M. A. B. Solution. A. Yes, L is parallel to M because we have angle 1 is equal to angle 2, which are forming a pair of alternate interior angles. B. Angle 1 is equal to angle 3, vertically opposite angles. Therefore, angle 3 is equal to 120 degree. Angle 2 plus angle 3 is equal to 60 degree plus 120 degree, which is equal to 180 degree. Since angle 2 and angle 3 are consecutive interior angles and their sum is 180 degree, so the lines L and M are parallel. Example 5. Find the value of X in the given figures if L is parallel to M. Solution. Angle 1 plus angle 2 is equal to 180 degree. Consecutive interior angles are supplementary. So, x plus 2x is equal to 180 degree. 3x is equal to 180 degree. This implies that x is equal to 180 degree by 3, which is equal to 60 degree.